Okay, sir. Am I audible now, sir?
Yes, sir. You are clearly audible, and you may start your session.
Okay, sir. Thank you. Thank you. Very good morning to everyone. Today's session is about the Trainset Bogies. So let me straight away start the presentation. Uh, My screen is visible to everyone.
PPT is visible.
Visible. Okay. First of all, the Trainset Bogie. Before going into the Trainset Bogie, a brief introduction about the bogies, whatever we have in service that we will present, and then a small brief about the bogies I will give. Then about the bogie frame, how the bogie frame is manufactured with the welding. That one more presentation will be there. Then a brief presentation about the balancing requirements for the wheel. That also I will share. Then one more presentation, that will be a lengthy presentation about the Train 18 bogie disassembly procedures that I'll present. And then right now we are facing some issues in the two rakes of Vande Bharat Express, that is the Trainset bogies. I'll share a few slides about that also. So let me start with the introduction to Train 18 bogies now. Now, as all of you are aware that ICF is so long manufacturing bogies for EMUs, and now three-phase members also produced with the same bogies. Here, this bogie is designed to cater for 20-ton axle capacity motor coach bogies. And then the major features of these bogies are it is with self-flanging spherical roller bearing. And then in the secondary, primary suspension is with the conventional dashpot arrangement with the coil springs. And secondary is initially we have provided 150 kilonewton air spring. Later on, it is changed to 180 kilonewton air springs. And it is with provided with the vertical dampers, lateral dampers, like that. And then the loading is through the side bearer. And all of you are aware that this bogie is with there is the conventional ICF bogie. It is facing lot of troubles in maintenance. Frequent maintenance is needed. Like that, the bearings has to be re-lubricated for once in every 3 months, and side bearer oil has to be filled. Then this dashpot oil has to be filled. Then the brake rigging components, that is that nylon bushes are there, brake gear pins, chromium plated pins are there. They require replacement in every POH. And there are a lot of wear related components, that the brake block, of course, brake block is always wearing. Then other that is the damage prone components like the pull rods, then brake beams. They need periodical replacement in service. So this bogie is designed to maximum speed for 110 kmph only. So because of the axle capacity, this bogie is not suitable for higher speed capability. So these are all the disadvantages. Even though this bogie is with the 20-ton axle capacity, higher speeds cannot be achieved with this bogie. Next, this is a EMU trailer bogie. In the same, it is similar to the motor coach bogie, except the traction motor. All features are common in this bogie. Even the main major components are common. Only the wheel and axle set will be different, and the bogie frame will not have the brackets for the nose suspension. Then one more bogie is the bogies used in the demo trailer bogies. Of course, this is similar to the bogies used in the ICF mainline coaches. This bogie is common for 1400 HP and 600 HP demos. And this bogie is also provided with 180 kilonewton air springs. And the major components are similar to the ICF mainline coaches. Here also the problem is the grease has to be replenished for once in 3 months, and then the dashpot oil has to be periodically filled, side bearer oil periodically filled. Like that, there are many maintenance related issues in this bogie. This bogie is also capable of running at 110 kmph only, even though its axle capacity is 16.25 tons. The suspension system don't permit it beyond 110 kmph. And all of you are aware that we are manufacturing LHP coaches fitted with Fiat bogies. So this bogie is the now mainstay for Indian railways. The ICF bogies, the previous the regular design ICF bogies, they have been stopped. There is no further production of that. Now all the coaches are manufactured with the mainline coaches are manufactured with the Fiat bogies only. This bogie is capable of running at 160 kmph. But the problem is we cannot provide traction motors here. There is no space. So next is Fiat bogie with air springs. Only the secondary suspension is replaced with the air springs. All other components remain same. This also this bogie can also run at 160 kmph. And the major problem is here also the traction motors cannot be mounted here. So here comes the Train 18 bogie. So this is a new generation bogie, only 2-3 years old. Here, if you see the motor bogie and trailer bogie, it is almost common, except for the axle and some brackets in the brackets for the traction motor. All suspension elements like primary springs, rubber metal elements, bearings, secondary springs, all dampers, they have been standardized. Some of you may ask why Fiat bogie cannot be used for the trailer bogie. But due to standardization and ease of maintenance, the trailer bogie is it's made similar to the motor bogie here. So some of the features of Train 18 bogie, Train 18 and Trainset bogies. This bogie is bolsterless bogie. That means the coach or the car body is directly seated over the air springs. You can see this is the air spring and 4 lugs are there. So the car body is made to sit on the air springs and the 2 air springs, and with the bolt and nut, this is clamped with the car body. So this means that one bogie bolster is eliminated. In Fiat bogies, if you see bogie bolster is there. So here the one major component bogie bolster is eliminated here. And this is tested up to 180 kmph and fit for 160 kmph. And the maximum axle load has been restricted to 17 tons by suitably distributing the other equipments, transformers, compressors to the adjacent coaches. And one of the main problem in the ICF mainline coaches is the self-hanging spherical roller bearing that has to be periodically lubricated. Here, this bogie is provided with the CTRB similar to the Fiat bogies. So the periodical lubrication, that issue is avoided here. And primary suspension with helical springs designed to particularly designed to this bogie and with the external damper. And secondary suspension with the air springs and similar to the Fiat bogies, vertical, lateral and yaw dampers are provided. In Fiat bogies, if you see the lateral damper is one number per bogie, whereas here in this Trainset bogie, we have provided two lateral dampers per bogie. And additionally, to control the rolling oscillations, we have provided stabilizers, or we call it an anti-roll bar in Fiat bogies. So the similar mechanism is adopted here in this Trainset bogies also. Bogie frame, that is the without brackets, it is common. So additional brackets are provided for the Trainset bogies in the motor coach bogies to mount the traction motors. And one more major advantage of this bogie is designed to fit the traction motors directly to the bogie frame. If you see this traction motor, this is directly fitted to the bogie frame. In previous this EMU bogies, the traction motor is axle hung and nose suspended. That means that the traction motor is rigidly fixed to the axle suspension tube, and the motor's nose will rest over the rubber suspension which is fitted to the bogie frame. So the traction motor, major part of traction motor weight is becomes unsprung mass. Whereas in this setup, the traction motors are directly fitted to the bogie frame, and it is driving the gearbox through a flexible coupling. So the traction motor's frame can be made lighter in weight and compact. So the one more advantage with this system is unsprung mass is reduced, that leading to less vibrations and improved comfort in the bogie riding. Now, already we have two rakes of Vande Bharat Express with the same concept, same design. And now we are going to shortly we will be turning out this train set with new design bogies. So some similarities and differences I am trying to find out with these bogies. Here with the experience gained in the overhauling of the first two rakes of Vande Bharat Express, we found that the traction motor is the traction motor in the earlier train set rakes is self-ventilated. That is, filters are built into the traction motors. That in our Indian condition, this attracts a lot of dust in the running, and fine dust accumulated inside the is getting accumulated inside the traction motor. Though it is the filters are effective and the performance of the motor is not affected, in long run it will give trouble to the motor. So in this new design, they have provided a MEDA has provided a flexible element in between the car body to the motor air inlet. So this similar to the regular EME bogies, the filters will be in the coach, air filters will be in the coach. Through that filtered air will be sucked through to the traction motor, and it will be exhausted through this outlet. So this will enable more cleaner environment for the traction motor. This is a major improvement being done on the current design Trainset bogies. And the CP bin design has been improved further to reduce the chances of loosening of the fasteners, and also to reduce the weight. Some cutaways have been introduced here. And primary springs is further fine-tuned to cater to the axle load and the payload. And the air springs is also further fine-tuned to improve the riding. And CTRB, it is now previously it was the Train 18 bogie, though it is axle load is less. And the bogie was designed to cater for EME applications also. So we have provided a 21-ton axle capacity and suiting bearings, CTRBs. Now in this train set, this is exclusively designed for the train set bogies. So the bearing has been redesigned in similar lines for the Fiat bogies. And then to suit the bearings, control arms, and the other parts of axle box have been redesigned. And in the bogie frame, spring part has been further redesigned to accommodate the primary suspension. The plate thickness have been optimized to reduce the weight. And some rubber metal bonded items like CP pin bush, then the control arm bush, they have been redesigned to improve the riding. And dampers also have been, the characteristics have been redesigned for further improvement in the riding. And wheel and axle. So here also we have increased the primary spring spacing to get more rigidity. And wire rope, that is body bogie connection wire rope, they have been redesigned. Length has been increased to further cater for the increased ride comfort. And if you see the common with the what are the common things with the Trainset bogies? Here we have kept the car body interfaces unchanged. That is where the air spring seating and the hole sizes for the fasteners, for the level from rail level, and the hole sizes for the dampers, CP pins, all these interfaces are unchanged. And then whatever brake is used in the existing train 18 is used in these Trainset bogies also. Here, if you see in the Fiat bogies, here the brake discs are mounted over the axle. So, so the brake caliper unit is fitted to the bogie frame. This is the bogie bogie frame bracket over which the brake calipers are fitted. So there is no space to provide the traction motors here. So here in this Trainset bogies, the brake caliper unit has been brought outside of the bogie frame. Here it is mounted. You can see it here. And then so the total area between the axle and the bogie frame is free to provide the traction motors and gearbox. And because the brake caliper units have been brought outside to relieve the axle from the brake disc, the brake discs have been fitted to the wheel, directly fitted to the wheel disc. So this is wheel mounted brake disc. So then so far we have talked about the motor coach bogie. Then coming to the trailer coach bogie. Trailer coach bogie is also has been improved with the provision for TPWS. TPWS means train protection and warning system. This is that bracket for that. We have connected with the beams with the bogie frame end, and TPWS that magnet can be fitted underneath this bracket. And this bracket is for provision of TCOS, that is train collision avoidance system. That also that provision has been made in this bogie. And one more thing is APC, that is automatic power control. That sensor also can be mounted over these brackets. So this bogie is future ready. Any improvements over the train operation can be very easily incorporated in these bogies. The basic frame, that is this side frame and the transom is almost common with the motor coach bogie, so that the manufacturing can be done faster. And similar to the train 18 bogie, all the dampers, all the suspension elements, rubber metal components is common here. The CTRB is also common here. And this is a comparison of Fiat bogie and Trainset bogies and IRIMEE bogies. You can see the major, this PPTs will be shared to IRIMEE. You can have this. I am telling about the major points only here. If the wheel diameter in the Fiat bogies is 915. So this bogie, whereas with 915 wheel, the traction motors will not suit. So here the Train 18 bogie is we are provided with a 952 diameter, similar to the EME bogies. And condemning size is here it is 845, and the Trainset bogies it is similar to the EME bogies 877 mm. And the major difference in the wheels is this is with the curved wheels. Both EME bogies and Fiat bogies are with curved wheels. Here in the Trainset bogie, we are using solid forged wheels only, no cast wheels, and with it is with straight webs over which the brake disc will be clamped. And axle capacity, this is 16 ton Fiat bogie, and the Trainset bogie is 17 tons, whereas CME bogie is 20.32 tons. This is to cater the suburban services. So this bogie is unsuitable for the 17 ton axle capacity, which is demanded for higher speeds. Then others are explanatory only. I'll go to the next slide. And the brake unit, as I explained earlier, the brake calipers in Fiat bogies are provided in between the axle and the bogie frame, inside the frame. And that is axle mounted brake disc. Here it is calipers are brought outside the bogie frame, and the maintenance will also be easier with these Trainset bogies. And EME bogies, as you all aware, it is 8 inches JSL type brake cylinders. This requires a lot of brake rigging, additional brake levers, brake beams, etc. Whereas here in these two cases, they are all built into that caliper units. And others is Fiat bogie is it's basically it is a bogie with a bolster. The car body will be rested over the bogie bolster only. Here the car body being bolsterless bogie, it is the car body rests directly on the gear springs. Then additional sensors, that is for the WSP system, that is wheel slide protection. Similar to the Fiat bogies, same system is used here. And the traction motors are mounted to the directly fitted to the bogie frame. So through traction motors, we cannot provide axle earthing. So the axle earthing is through the separate earth return brushes provided to the axle ends in this Trainset bogie. And you can see the bogie weight here. It is only 6.635 tons Fiat bogie, whereas Trainset bogie for the motor coach bogies it is 10.5 tons, and trailer bogies it is 7.21 tons. It is marginally almost 0.6 tons higher than the Fiat bogies. Whereas in the EME bogies, if you see that it is 10.793 tons, 10.8 tons almost. Here, if you see it is even though it is 20 ton axle capacity, the weight is less here. But the unsprung mass, if you see the unsprung mass, it is 6.68 tons for the. Sorry, not unsprung mass. It is bogie weight for trailer coaches. Unsprung mass it is here. It is 6.2 tons for the EME bogies, whereas it is only around almost 4 tons for the motor coach bogies. So reduced unsprung mass will give better riding. And yes, a brief comparison about the motor rating. Here it is 268 kilowatts, and here it is 210 kilowatts. Yeah, Trainset bogies are 210 kilowatts. The reduction in motor rating is compensated by the additional motor coaches. That is, the Trainset is designed for 50% powering. Alternate coaches will be powered coaches. So that with this power, we can able to achieve the desired acceleration and deceleration. Now we'll go the step by step of the components. Now this is slide about the wheel and axle. For trailer bogies, it is there is its plain axle in between the wheel seats. For the motor coach bogies, there will be steps to mount the gearbox and the gear wheel bearings and all. And then wheels will be straight webbed, and you can see here these are all the brake disc, both sides of the fitted to the both sides of the wheel web, and this is the brake disc, you can see. And right now these wheels are supplied by Bonatron, and for the new train set it will be from KLW. This slide is about the comparison between the curved web and straight webbed wheels. You can see this is all along we were following this curved webbed wheels. Now this is the straight webbed wheel for this Trainset bogies. Here it is the straight, this web will be machined to mount the brake disc. You can see the tolerance here. It is plus or minus 0.1. So it with the wheel disc is made with great accuracy. And CTRB, similar to the this bearing is similar to the Fiat bogies, but not same. It is similar to the Fiat bogie. It is the 130 mm channel diameter, and OD is 230 mm, and overall length of the bearing unit is 160 mm. And right now, as in the Fiat bogies, there are two suppliers, Timken and SKF. The existing train 18, all the bearings were supplied Timken, and that bearing is suitable for 21 ton axle capacity. So the OD is higher in that bearings. So this time for this currently manufactured coaches, this bearing has been redesigned to suit the 17 ton axle capacity. Next is the various components of the roller bearing suspension and axle and equipments. This is control arm. The control arm is fitted with a rubber metal bonded item. The control arm bush is fitted here, and inside the control arm, one bush is there. Then the control arm is in two halves. That is top side control arm and bottom side control arm. And the front cover, rear covers are also of different designs are available. That is to suit the axle and equipments. Here, if you see, this front cover is suitable for mounting ERCU, that is the earth return current unit, and this front cover is suitable for mounting the phonic wheel sensors. This is a phonic wheel sensors. And then this front cover is suitable for mounting the tacho generator or pulse generator for speed sensing. Rear cover is common here. The one more improvement done over the Fiat bogies is the Fiat bogies, there are a lot of issues in the phonic wheel fitment. Phonic wheel in Fiat bogies, it is fitted with through just a M8 screw. The screw breaks in service, and a lot of hot axle has happened. So we have improved the fitment of phonic wheel here. The phonic wheel along with the security disc is fitted directly to the axle end through a single screw. So the chances of failure of this screw, phonic wheel fitment screw, is avoided here. So this is for axle earthing, ERCU fitment. Here also we are using the different front cover here. And this front covers is made to SG cast iron material, ENGJS 700. That material that grade is used here. It's a high strength cast iron. And bogie frame. Major parts of
the last slide again, sir, please.
Sorry, I couldn't.
Please explain the last previous slide, please.
Previously. This is about the axle end equipments. In the Fiat bogies, if you see this clipping is about the Fiat bogie. The phonic wheel for the WSP sensor that is fitted to the security disc using M8 screws. So there are many issues in the fitment of these screws. Because being a small size screw, they fail in service. They even while fitment also they fail. Often the technicians apply torque and they see the screw heads are shared. So this is always a problematic area in the Fiat bogie. So here in this Trainset bogie, we are similar to the phonic wheel. A different design phonic wheel is adopted here. Number of teeth will be same, but the phonic wheel forging and the machining has been changed to for direct fitment to the axle end. So this is the security disc. This brown color is a security disc, and this is the phonic wheel, separate phonic wheel. It is fitted along with the security disc directly to the axle end. So this separate M8 screw is avoided here. Are you able to follow?
Yes, sir. Yes, sir.
Then I was telling about this cover material. This is SG cast iron covers. High strength SG cast iron is allotted for the covers. This is rear cover. This is rear cover, and the high strength materials, that is SG cast iron is available, not steel casting. This is SG cast iron. And shall I go to the next slide?
Yes, sir. Thank you.
So this is this slide is about the major parts of bogie frame. As you are aware, there are two side frames, LH and RH. And this in side frame, this spring part is cast material. Casting to this is the grade EN 10293 and to this G24 MN6 plus QT. So this is also a high strength steel casting, weldable casting. And the other plates are made to that is S3 with J2W plus N, weather resistant steel. This is actually this is similar to the cotton steel. The yield strength will be 355 Newton per mm square. And then they are welded together. There are many butt joints here. And the plate thickness is 12 mm and webs are with 10 mm. There are many differences in the plate thickness to suit their requirement. And the transom, if you see the transom, it is also made in different cross sections. So this is a major sub-assemblies of the bogie frame. And next is the primary components of the primary suspension. Here, similar to the Fiat bogies, this primary spring directly is rested over the control arm, top of the control arm. And there are inner and outer springs, and over which we are providing the rubber metal bonded item. And this is the shims. As you see, the motor coach bogie and trailer coach bogie are common. So by varying the shim thickness, we can achieve the bogie required, the bogie clearances here. And the suppliers of rubber metal components are Mrs. GMT. And for this Trainset bogie, the MEDA will be providing the complete bogie. The springs will be from Mrs. Axstone and Gruber. Both the companies they have entered, they are buying from these two companies. The assembly is after the wheel set assembly, the bearing will be pressed, and over which the bush and the other axle and equipments are mounted, and with the control arm. Then over which the bogie, over which the primary springs are placed here, and the bogie frame will be lowered over the complete setup. One more thing here we have to notice the placement of primary springs. There is a particular fashion has to be followed, that lateral deflection has to be towards the outside of the orient towards the outside of the bogie. That has to be followed. That we will give in the assembly instructions. Then after lowering the bogie over the springs, it is the control arm is pushed inside the brackets and locked using additional piece. And then this vertical damper, primary damper, is screwed to this frame. Here the bottom mounting is the flange type mounting, and top mounting is through bolt and nut here. So this is an improvement over the Fiat bogie. Fiat bogie, both sides are fitted with the flange type mounting. There are some issues in the Fiat bogie. So here the top mounting is with the bolt and nut. So the failures encountered in Fiat bogie will not, I hope, will not happen in this Trainset bogies. And then the lift stop is bolted here. This is a lift stop. This bracket, the J-type bracket is a lift stop. It is bolted to the bogie frame. And this is the lift, that is vertical stop clearance here. And for the bump stop, we are providing one steel bump stop to the bogie frame that is permanently screwed to the bogie frame. And over the control arm, the rubber metal bonded bump stop that is provided to this. This acts as a spring guide also. So this is the bump stop screwed to the spring guide. This will be placed over the control arm, and this separates the inner and outer spring here. And this bump stop, that is steel bump stop, that is a tube welded with the two closing plates that is screwed to the bogie frame. So if you see in the Fiat bogies, this bump stop is welded to the bogie frame. You cannot make any adjustments, or if anything happens to the bump stop, the bogie frame has to be should be repaired extensively in Fiat type bogie frame. Here, this can be renewed by just by unscrewing, and new bump stop can be replaced. And you can see these are all the shims. The overall part is the spring part in the bogie frame, and similar to the rubber metal bonded, similar to the Fiat bogies, rubber metal bonded, the item is placed over the springs here. So this height is important here. While in the primary, after assembling of the bogie, in the load testing machine, this height will be measured, and if necessary, this shims has to be adjusted to suit the height. Now this is a view of bogie with completely assembled with the primary suspension. Now let us go to the secondary suspension components. The major components of secondary suspension is this traction center. So the traction center, this is a steel casting, and it is provided with a bush, that is CP pin bush, which is pressed inside the traction center. And to the traction center, it is machined. The traction center is completely machined, and the traction bar, or we call it as anchor link also, it is bolted to the traction center. So this complete assembly is brought to the bogie, the previous one, the bogie, the primary suspended assembled bogie, and it is raised through this. And before that, this bogie is fitted with the lateral bump stops. The both sides, it is fitted to the lateral bump stop. The lateral bump stop will engage in this area of the traction center. So this is how the lateral bump stops will be screwed here. It's a machined portion in the bogie frame through which the bump stop will be fitted here. And there are shims in the bump stops. So through by adjusting the shims, the lateral clearance can be controlled in the desired values. And then this assembled traction center with the traction bar is brought up and screwed to bolted to the bogie frame here. And then other items, that is the stabilizer assembly, that also it can be from the bottom side of the bogie frame, it can be lifted and bolted through the brackets here. Next is yaw spring. The main, now the bogie is completely assembled with other parts. Next is fitment of the yaw springs over the bogie frame. Here the yaw springs are a different design. You see, this is a stump, one spigot projecting below the yaw spring. So that will be seated over this the machined area in the bogie frame. The stem or spigot will project inside the bogie frame. So that will additionally, we are providing the fasteners also. So this will prevent the the air spring from tilting. And while removing the air spring from the bottom of frame, this can be pushed up. So the disassembly can be easier. And then the components which are all fitted to the car body. Now, with this provision of air spring, the secondary suspension on the bogie frame part is over. Now, there are some components to be fitted to the car body side. That is the stabilizer link and the wire rope. Here, the wire rope has to be provided. And then the CP pin has to be bolted to the car body. So, with this, the car body and components for secondary suspension is over. Now, after lowering the coach over the bogie, the fasteners has to be fitted to the that is the wire rope and the stabilizer link, and CP pin has to be engaged with the traction center bush and pushed the and from the bottom side one plate has to be mounted over there.
Excuse me.
Sir.
Just in previous slide, you have told that one pin has been provided in air spring to prevent the tilting of the air spring.
Yes.
Earlier air spring was also fitted with 4 bolts.
Yes.
So, do you have any data of tilting of a case of air spring during the service?
Yes, this problem is frequently encountered in the IRIMEE bogies.
You have any reported case?
Report that is. There are many causes for that, because the air spring seating area in the IRIMEE coaches, it is not machined. It is not if it is not flat, then there will be a tilt. Similarly, the bogie bolster seating is also not machined. It is the directly the welded plate. It is used here. It is used in the IRIMEE bogies. So the tilting of that air springs, the different bogie bolster clearances, that problem is still there in the IRIMEE coaches. Here, if you see in the bogie frame, this one more plate is welded here, and it will be machined in a single setting. And the dimensions will be controlled with respect to the control arm bracket. So the air spring, we get a flat surface and perfect surface for air spring seating. This prevents this it is improves this spigot further improves the seating of the air spring. And in the top side also, in the bogie bolts, in the car body side also, this air spring seating area is machined in the body bolster after welding of the body bolster. After welding of the body bolster components, it is machined in a single setting. So we get a flat, perfect surface for air spring seating here. So the difference in levels between the two areas of air spring will not happen in these bogies.
Of course, it will provide more stability, but I think we have not any reported case of air spring, tilting case of air spring on this account. I think one more complication will be in this present bogie. The lifting of bogie will be more in comparison to the previous design, because we are providing this pin, so we have to lift our coach to remove the air spring, or we have to when we want to remove this air spring, we have to lift the coach this enhanced height, adding this pin height. So I think I could not understand why this has been provided, because in existing cases we have not any such type of reported case. That air is, we are giving proper torque, we are tightening torque about I think 175 kilonewton, and no such type of cases is reported in IDSO, I think, on this account. So this is an additional exercise during the lifting of the coach or removing the air spring from the bogie.
Yes, yes. Here it will be
Sorry
easy.
to interrupt. Actually,
Shall we go to the next slide then?
hello?
Yes, sir, of course. If anybody can explain,
Yeah,
yeah, give their view in this regard, please.
sorry to interrupt. Can you hear me, Sabhavdi?
Yes, sir. Yes, sir.
Yes, sir. Actually, for removing the air spring, we require to lift only the shell, not the air spring. So,
Sorry, your voice is very low, sir.
for removing the air spring, we have to lift the cell body to the height up to the spigot. The spigot insertion is there between cell body and the air spring. To the level of spigot, we have to lift the cell body, and the air spring can be
நான் 11 மணிக்கு மேல தான் என்னால வர முடியும்.
air spring can be removed again by lifting from the bottom. Sir, the below is flexible.
அதுல train it description.
Yeah, this particular spigot is kept there to ensure that the same location of the air spring is provided in all coaches. That is, it will not permit any rotation, as well as it is giving additional support to the air spring. Like in EMU, the air spring is not directly loaded. Here there is no bolster, bogie bolster. It is bolsterless bogie, and the air springs are directly loaded to the body load is directly coming to the air spring. That is why the additional position is kept there. And in train 18, made only 2 rakes. It is running, so far no complaint has come. But when we go for a large number of rakes, this may happen. Sabha, you can continue.
Okay, sir. Next slide is about how the vertical load is vertical load transfer is happening in Trainset bogies. Here, as I told you earlier, the car body is directly seated on the air springs. So the vertical load from the car body will be directly over the air springs, and then through the air springs it is coming to the bogie frame. And bogie frame, it is shared over the primary springs seated over the control arm. Then control arm is once again, it is clamped over the bush, over the bearings. So through control arm, through the bush and the bearings, axle and then wheel. This is how the vertical load is transferred to the rail. And transfer of tractive forces. Here this is a push-pull rake. That is in between the adjacent coaches are powered coaches. So the torque developed in the traction motor, it is transferred to the flexible coupling, and the flexible coupling drives the pinion, which drives the gear wheel mounted over the axle inside the gearbox. So the torque transfers from the motor to the gear wheel through the flexible coupling, and then from the axle, it is through the bearings, it is transferred to the bush and control arm, and then through the control arm, rubber metal elements inside this control arm, and to bogie frame. Then traction rods are connected to the bogie frame and the traction center. So through the traction rods to the traction center and the CP pin bush, CP pin, car body and coupler. This is how this tractive forces is happening in the motor coach bogies. In trailer coach bogies, because motor coaches push or pulls the trailer coaches in this formation, and through the coupling, the tractive forces from the motor coach transfers through the coupling in between the coaches and through the car body, then CP pin, then CP pin bush. That is the reverse of the tractive forces flow in the motor coach happens in the trailer coach. So through CP pin, this CP pin bush, and then traction center, and through the traction rods, bogie frame, then control arm bush, and then the bearings, axle, and then wheel. This is how the tractive forces is transferred in trailer coaches. And then braking forces. Actually, these bogies, these coaches are provided with regenerative braking. So the momentum of the train, of the total train, that is utilized to regenerate the current, and through that the traction motors give you a retardation torque that also achieved here. Then at the fag end of the halting, that is around 12 or 15 kmph, this friction braking happens. So here the brake discs are clamped by the caliper units. So flow of brake disc is the main part in the flow of friction braking, and then wheel, axle, bearing, bush, control arm, and similar to the tractive forces, the braking forces flows. So this completes the introduction to the Trainset bogies. Next will be a small presentation on the manufacture of bogies, manufacture of bogie frame.
Hello.
Sir,
Hello, sir. There is a class on air brake system.
air brake system will be dealt separately. I think this class is exclusively for bogies alone, sir.
Okay. Okay. One more thing. Where is the wire rope connected?
Sir,
Where is the wire rope connected? With which components?
wire rope. Oh,
Yeah.
I'll explain, sir.
Yeah.
Sir, where is the mechanical connection between the car body and the bogie and bogie frame?
Car body directly resting over the bogie frame, sir. So I'll explain that, sir. I'll go to that slide.
Sir, how parking brake are being established here, sir? With the brake caliper unit, I think you have told.
Brake piping is directly from the car body side to the brake caliper units through flexible courses only. There is no brake piping or air spring piping over the bogie frame. It is bogie is free of any brake piping.
Sir, parking brake.
Parking brake, that also I forgot to explain that. I'll explain. 1 second. I'll get the screen.
ब्रेक सिलेंडर
का और वो एयर
बाहरी-
का तो रहेगा सब। देखो,
अब कैसे किया है
ये
भगवान
स्प्रिंग
जाने।
का वही चाहिए।
Sir, one more thing. In AMUs, there is a 20-liter reservoir for air spring on bogie. So there is that one.
Please hold on. I'll just trying to share the screen. Just hold on. I'll explain all the questions. I'll answer all the questions.
Parking brake is part of the caliper, brake caliper. Already brake caliper is there for each wheel, and 50% of the brake calipers are equipped with parking brake. So every alternate caliper will have parking brake facility.
This share பண்ணணும்.
And regarding the aspirin reservoir, it is part of the brake system. There are module, brake system module, which is provided near the bogie, and there will be two 50-liter reservoir to meet the supply of the aspirin.
Sir, excuse me, sir, your voice is very low, sir. Please loudly say.
Yeah.
Sir, I am audible. I am trying to explain the question, sir. Here the first question is how the mechanical connections are there in the bogie frame. So here this is a bolsterless bogie. So the car body is directly seated over the air springs here. There are two air springs in a bogie. Car body straight away rests over the air springs, and there are 4 lugs here, and through that lugs it is clamped to the car body. Then one more mechanical connection is the center pivot. Center pivot is a separate welded and machined item that is clamped to the car body. Through these 8 bolts are there. Through these 8 bolts, it is clamped to the car body. And the bottom portion of center pivot pin that is engaging with that after the lowering of the car body, that engages with the traction center bush. So traction center bush has to be pushed up and clamped with the CP pin bottom side through fasteners. So this is a mechanical connection. Then further, the control arm. Control arm, the traction stabilizer link. I'll go to that slide.
Can you show the interface of body bogie connection also? Mechanical connection?
I'll show here. Here, the 2 more mechanical items are here. The one is wire rope, and this is the stabilizer link. The stabilizer rod along with the arm is bolted to the bogie frame. Now, this is the stabilizer link which is provided with the rubber metal element. One part, the top part is clamped to the body bolster, and bottom part is clamped to this this area here. This area, this is stabilizer arm. In this will be connected. I will show you the drawing also, so that you understand it better. So these are all the mechanical connections. So lift the car body, you have to disconnect the wire ropes, disconnect the bottom part of this fasteners, bottom part of this CP pin connections, and the bolts over the air spring top side. So you have to disassemble the bolts screws, and then you can lift the coach. And somebody asked about the piping. Here the bogie frame is free of any piping. All the piping is done in the car body, and the brake caliper units which are mounted to the bogie frame, they are connected through flexible hoses from the car body. So there is no piping in the bogie frame, either for the air springs or for the brake caliper units. And here the 50% of the caliper units are provided with spring applied parking brake. That is the diagonally opposite brake caliper units are built in with the parking brake units. So the purpose is this formation can run in the worst gradient of 1:25. The parking brakes can hold the rake in 1:25 gradient. Actually, it is in the Mumbai region. There is a worst gradient is there in the Lonavala section. The gradient is 1:25. So this without any backing loco, this formation can withstand in that 1:25 gradient. And the additional reservoir for the air springs. Somebody asked about that also. They are provided in the underframe. They are provided in the car body side only. There is no reservoir in the bogie frame. There is since it is car body is directly rested over the air springs. Here it is rested here. So there is in this area. There is a spike gut engaging with this car body through which the air enters inside the air spring. So from that spike gut, it is connected to the end pneumatic in the car body. And the leveling wall is also fitted to the car body only. Only the insulation lever of leveling wall will be connected to the bracket here. This is the insulation lever's bracket here. It is in the same side of the bogie.
It is inside the bogie frame.
Bogie frame? Yes, it is inside the bogie frame. Yes, sir.
Okay. And what is the capacity of additional reservoir?
It is 40 liters.
On air spring? 40 liters
40 liters, yes, sir. 40 liters per air spring.
per air spring. And main reservoir capacity?
Sorry. Main reservoir.
Main reservoir capacity for air spring.
It should be, I think, 125 liters. I am not sure about that. My brakes people, they know, so we know.
Earlier, I think it was 150 liter in ICF and hybrid mainline coaches. 150 liter.
Here it is 125 liters, I think so. I am not sure about that. I'll explain. Maybe in the brakes class, they may explain. I think Meda is taking a class on brakes also. Now they may explain it about that.
Sir, excuse me, please. Could you please explain how buffer height will be adjusted in this one?
Buffer height here only through the shims adjustment, and the air-spring height can be varied to get the desired buffer height. Air-spring is as in the regular EMUs. Air-spring height is here 300 mm. Here it is 300 or 260. 300, I think. The tolerance is +5 -0. So through that you can able to achieve. Here, since the coaches will be working in the formation, coupler height adjustment, the major problem will not be there.
No, but in case of one wheel or intermediate stage of wheel, how can we adjust the buffer height? Actually, it is cleansers are automatically adjusted with by air suspension, air spring. But in case of lesser dia wheel, how we will adjust the buffer height? Where we will provide the sims?
Here the bogie frame is welded and completely machined, and the gas spring seating is also machined, and the body bolster part which engages with the air spring is also machined. So the coupler fitment brackets, they are welded with respect to the body bolster. So the height variation will be very minimal only. In the first two rakes, we have not faced any issues so far. So that will in the manufacturing stage itself, it is taken care to a great extent. I hope
actually, sir, it will require in case of intermediate diameter of wheel. Suppose there is a new wheel of 915 mm, and the other is 870.
Yes. Okay. For that
required.
Yes, for that purpose, shims can be provided underneath the air spring. Underneath the air spring. So
bottom plate.
Yes, in this in between the bogie frame and the air spring bottom plate, shims can be provided. Already provision is there. So below this, it will be the shims can be added to suit the wheel diameter.
No, but sir, if you provide any sim between this air spring, then on same installation height, air cushioning air gap will be lesser in the air spring.
So air spring height will not be affected. Air spring height has to be maintained as 300 +5 -0 only.
No, sir, but suppose we have put 20 mm, suppose 20 mm sim to compensate the wheel wear and maintain the buffer height. So, and I think air gap between the top plate and the emergency spring, it is almost about to 30 mm or 40 mm.
One second, I'll share you that drawing. 1 second.
Cross-sectional drawing is available in the same sim slide.
1 second, I'm getting the drawing. Just I'll show you the drawing so that you can understand. தெரியுமா உங்களுக்கு இப்போ? Can you able to see the drawing now? Hello?
Yes,
Yeah.
sir.
Yes, sir.
This is about the mechanical connections for the car body side. So you can see gas spring fastener. Are you able to see my
Can you zoom this
screen
slide, please?
drawing?
Can you zoom the slide?
Sorry.
Can you zoom the slide? Yes, yes, yes. Now it is clear. Okay, okay, okay.
Now these are the fasteners fitted to the vertical damper in the car body side, and this is a fastener fitted to the air spring in the car body side, and this is the bracket on the car body, and this is the fastener. This is the mechanical connections for the damper and the air spring, and this is the fastener for the stabilizer link. This is car body side. This is the fastener here. And this is the body bogie connection wire rope. Here, this is the bracket on the car body side. This is bracket welded to the bogie frame. This is the pin joint between the wire rope and the bracket. And for the center pivot connection, this is the center pivot is bolted to the car body, and this is coming inside the while lowering. This center pivot will be coming inside this center pivot bush, and the center pivot along with the the control traction center along with the traction rod has to be pushed upwards, and it should be, we have to engage that it is we have to ensure that the engagement of the center pivot pin with this bush, and then one more plate has to be placed, and this is screws which will be going inside the tap the hole of center pivot pin. So this is these are all the car body side connections. Okay, then this is a ISO V of car body. And you can see this is the drawing about provision of shim for the wheel wear adjustments. So here underneath this air spring, we can provide shims to suit the wheel diameter. So here you can, this is the shim thickness table. Up to 932 mm, the shim thickness, we need not provide any shim. Then below 932 and up to 912 mm, we have to provide 10 mm shims here. Here, this is underneath the air spring, and below 912 and 892, we had to provide 20 mm shims, and below 892 mm, we have to provide 30 mm shims. While providing shims, this fastener height has to be increased suitably, and then this there is a provision for adjustment of this height, the stabilizer link height also in the stabilizer link. That has to be done to suit the height. And then there is a plate screwed to the bogie frame for the leveling valve. So that it is provided with slotted holes. So this hole also has to be adjusted to suit this height. So already this buffer height
So
adjustment.
this is actually, sir. Actually, this is the key point. You have made provision in labeling valve also to maintain the installation height of air spring. It means that whenever we put any washer or seams under the air spring base plate, then we have to fit the labeling. We have also to shift the location of labeling valve in the steps of 10 mm, 20 mm, or 30 mm, whichever is required.
Leveling valve
This
need
is the
not
process, sir.
leveling valve we need not adjust. Only the bottom connecting plate that is provided with slotted holes that can be lifted. So insulation lever
That will also that will automatically lift the spring, horizontal lever and labeling valve connection.
Yes, the leveling valve is
That connection will also lift accordingly.
Yes,
Okay,
we are
okay.
raising the air spring. We are raising the leveling fitment plate. So that will automatically adjust this. We will cater.
Okay. Now it is clear. Okay.
Excuse me, there is one question. When you put the seams below the air spring, then how the CP pin is adjusted?
Sir, this is, are you seeing this slide about this gas spring controlled reservoirs?
Okay.
Somebody was asking about the axillary reservoir capacity. Here,
Yes, sir. Yeah.
Here it is 75 liters axillary reservoir capacity, and the main reservoir is 200 liters. ASR reservoir is also 75 liters. Gas spring
75 liters, two reservoirs are 75 of each.
Yes. Gas spring reservoir, auxiliary reservoir is 75 liters, and one more reservoir for air spring is 75 liters here. They are mounted adjacent to each other. And the main reservoir is 200 liters. And this is
for brake power. It is in brake system. 200 liter is for brake system, and 75 liters of two reservoir are for air suspension.
Yes, yes,
correct.
sir.
Yes.
Yes. And the additional reservoirs are mounted at the end. This is called the end pneumatics. The additional reservoirs are mounted here. So it is 40 liters reservoir capacity per air spring. And this is the pipeline running from the air spring spigot to this end pneumatics.
Okay.
So this is a trailer coach. Here the compressor is also mounted here. You can see the. With there are 4 compressors per rake of 845 liters per minute capacity. Okay, we will go to the next presentation.
Excuse me, I raised a question. When you put the seams below the pneumatic suspension, then it is expected 20 mm, say 20 mm seam is there, then 20 mm coach height will be increased. So how the CP pin will be engaged with the bogie?
Sir, I couldn't hear you properly, sir. So our voice is so weak, sir.
Oh, let me increase it. Am I audible, clear?
Yes, sir, now clear, sir.
Okay, I raised a question. When we put 20 mm seam, say 20 mm seam below the pneumatic suspension, secondary suspension, then it is expected the coach height will be increased to 20 mm.
Yes, sir.
In that situation, how the CP pin will be engaged with the bogie?
How?
How the CP pin will be remain engaged with the bogie?
Sir, it will be pushed upwards, sir. Actually there are rubber metal flexible elements in the traction rod, so they can swing about the fixing points. So the control arm, the traction rod will swing about the fitment in the bogie frame. It will swing upwards, sir, to engage in the CP pins.
So it will be also raised to upward. Okay.
Shall I go to the next slide, sir?
Yeah.
See this. Chinese. Okay. So it's a brief slide about the bogie frame manufacturing. Here, different plate thicknesses are used. So there are so many butt joints in the bogie frame. I'll go fast in these slides. So it's a manufacturing is tedious for this bogie frames. There are so many butt joints with radiographic quality. Here, if you see, this is the side frame, and this is spring part made up of casting, and there are so many joints here. These vertical joints, and as well as horizontal joints between the side frame and the end part of the side frame. They are all to be welded with CPB quality, where we have to achieve radiographic quality welds. So we have in the previous.
वॉइस थोड़ी कम आ रही है, प्लीज.
Voice matter. Now am I clear now?
हल्का सा इम्प्रूव हुआ है, लिटिल बिट इम्प्रूव्ड ओनली.
Voice is clear. Please, other members check.
Okay, I'm going ahead.
Okay.
It's
Now,
clear. Voice is clear. Okay.
Okay, sir. I'm going ahead. Now, please, in some weld joints, we can provide and leave the backup plates. But in some areas, we can remove the backup plates. So the MR means removable backup plates. And in some areas, in these areas and all, it can be the backup plates can be left as it is. So similarly, the butt joints between the transom and the side frame, they are also to be radiographic quality welded. And then the brackets over the brackets for the mounting of control arm, brackets for the mounting of reaction arm of the gearbox, that has to be there. They are also to be welded with CPB quality. And then one more groove weld, that is also this is the lift stop bracket that is to be welded with radiographic quality. And other areas, they are with CPC2 quality here. Here we have prescribed 100% radiographic, or that is radiographic testing for the CPB quality welds. This is as per the standard EN 15085. And in side frame, in the bogie transom also, some joints, butt joints are there. You can see this is the backup plate in that. And this is prescribed as a CPC2 quality. So no butt joints is necessary here. And in the sub-assembly stage also, there are some joints which require CPB quality weld. So there are totally 62 joints, butt joints are there. So the welding has to be done very, very carefully. Then after the complete welding, the bogie frame is machined over this air spring seating area. This boring is done, and then the control arm. First, with reference to the control arm bracket, only first the machining will be done with the control arm brackets, and with getting reference from this control arm bracket, all other machining will be done. In the total spring part area will be machined. The holes will be drilled here, and then air spring seating, then stabilizer seating, then this traction motor spitment areas. These brackets, this is the brackets for traction motor, and then one more bracket for traction motor. All are welded, all are machined after complete welding. And this bracket is for the traction rod. It is also machined after complete welding. That's all, sir. I will go to the next presentation about the wheel balancing.
Sir, machining is done after before after welding, stress relieving is done and then only machining is done and started, na, sir?
Yes, the bogie frame involves extensive welding. So stress relieving is 100%. It should be done. After stress relieving only, the bogie frame is it is taken up for machining.
Stress relieving is done in single stage, or there is some intermediate welding and stress relieving stages also there in during the manufacturing of bogie.
Right now, we have prescribed stress relieving after complete welding. Stage by stage also can be done. That we have to see in the manufacturing during the bulk manufacturing. We have to check that so that the distortion can be controlled in the total assembled bogie. That we have to check in the detailed manufacturing stage. We have to check for the first two rakes. We have done stress relieving only after the complete welding of complete bogie frame. Then only then stress relieving done. For this regular updation, regular manufacture, we can go for. We have to check it once again. Now, right now, it is confirmed. Our boss has told that it is only after the complete welding stress relieving is done.
Actually, there is a lot of joints, 62 butt joints. So
Yes.
I think there will also be required some stress relieving intermediate stages also, because the distortion or stresses will be accumulated in 62 joints. So either these operations will be all weldings will be done in automatic welding by automatic welding process in 3 or 4 stages.
Wherever
I think
wherever straight welding is involved, we can go for robotic welding. But wherever there is some curves, we have to weld them in fixtures. Use of fixtures is extensively is recommended for this manufacturing. For the first frames, first two rakes, there were some delay in manufacturing because of the extensive welding. But for this current this one, we can I think we can go ahead. One second, my boss is calling. One second.
okay.
Sir, next slide is about the wheel balancing. In feed bogies, if you see, the wheel balancing is easier with the addition of counterweights. Whereas here, because the straight curved wheels, the brake disc will be mounted over the wheel disc. Wheel balancing is a little bit difficult. So wheel balancing has to be achieved in the detail stage of wheel. So here this is less than 200 kmph. So the maximum static imbalance is 75 gram meter. And this balance is achieved through this machining by inner rim portion here. So maximum 4 mm material can be removed in the segment. And the balanced portion is marked by punching in the wheel hub. Here the punching is done. And as you see here, this is from the clipping from the specification. This is less than 200 kmph, more than 120 kmph. So the imbalance is 75 gram meter. You have to restrict the unbalance within 75 gram meter. And for all the wheels, the static imbalances will be done. And this is a slide about how the balancing is achieved. So a small video will be there. I am pushing the video to. In the balancing machine, the wheel is checked for the unbalance. You see, you are getting around 500 grams unbalance. Now the tool gets moved to machine the wheel. The wheel is locked over the table. Now, in this inner rim area, machining is done, milling by milling. You can see it is not running fully, only one portion of the inner rim is machined. Now, once again, it is checking the unbalance. So here the unbalance is reduced from 500 grams to 50 grams. So this is within acceptable limits. That's all, sir. So I am stopping the video. So this wheel balancing at wheel stage itself is important by removal of material. Next is the subassembly of wheel with the brake disc. Brake discs are also balanced by 16 gram meter, and it is marked in the brake disc. So while assembling the brake disc, we have to follow the procedures given in the specification. So the static imbalance in the brake disc and the static imbalance in the wheel, they should be in the opposite plane. That while assembling the brake disc, it has to be followed. So these instructions are given in the drawing also. This has to be scrupulously followed while replacing the wheel disc in the workshops. And the assembling the wheels over the axle, that also we have to be careful. It cannot be done in the just like that manner. The counterweight, the balancing the mark has to be in the same plane of the axle. So for the both wheels, that has to be ensured. So if you see, the counterweight is not suggested, but in the extreme case, the counterweight has to be pasted 5 mm inside this rim towards web, so that it will not hinder the movement of brake caliper unit. And the dynamic balancing followed for the Fiat bogies, that is 320 RPM, that can be followed for this rakes also, because the speed is comparatively, it is nearing the speed, the surface speed of the wheel. And already we are having locomotives with the wheel mounted disc brakes. The WAP5 loco, you can see here, it is with the wheel mounted disc brakes. So the experiences gained in this from this locomotive can be used for wheel balancing for the train set bogies also. Thank you, sir. One more, few more slide. I am skipping the train 19 bogie disassembly procedure. I will go to the issues faced in the trainset bogies. In the first two rakes of train 18 Vande Bharat Express, there were some issues faced. So I'll very few slides about that. You see the rear cover is independently screwed to the bush using the Hessenett screws. If you see there is very little space between the wheel hub and the screw head. So conventional torque wrench cannot be used here. So you have to necessarily buy the open-ended torque wrench. So in ICF we bought that, and after that there is no complaint from this. Only one case has happened. In this like this loose rear cover in the first rake. And there are some failures in the springs also. So the various reasons for spring failure are the heat treatment of springs are not up to the mark. So not particularly in one batch. So the almost 12 failures has happened. So this time we are extra careful in that. Only after the fatigue testing of the springs, it will be fitted to one more reason for the spring failure is the pitting corrosion occurred over the springs. So here how the corrosion happens is due to the cattle run over, the slush that is splashed over the bogie frame, it is collected over the control arm top. So even though we provided a drain hole here, it is choked in service. Some dirt getting accumulated in the service, and that slush because of the cattle run over and the mud and the rainwater and the water from the wash basin areas, they splash over the bogie and accumulate over the control arm. So that dirt and water, they started corroding the springs. So that also one of the reasons for the pitting corrosion and further failure of the springs. So this time that control arm has been improved further. To improve the drainage, it is made a big hole here. You can see this is old one, this is new one. On both sides of the control arm, the drain holes have been provided here. And there was a complaint about the minute vibrations inside one particular coach. Even I have traveled in that coach. It is not giving much trouble, but we found that while machining the wheel tread, the one wheel profile is not maintained. So whatever the wheel profile has to be adapted for the different wheel sizes has to be scrupulously followed to avoid this type of complaints. And then one more complaint is about the safety bracket clearance. Here we have made the safety bracket of the traction motor as well as the gear case fail-proof for fitment. Even then, somehow it got fitted in the reverse side. So this side this time we are providing one more hole here. So this hole should be in the top side. Like that we have changed the design. And few more suggestions to railways. These bogies are very carefully made, very carefully designed to give a better service in railways. But during POH, I have seen many workshops. They adopt simple tactics to disassemble the bogies. One of them is to use the gas torches to remove the gasket fasteners. So that practice should be avoided at any cost. That will affect the gasketing, the hardware will affect the brackets and will affect the rubber metal components. It will alter that grain structure of that component itself. So that will lead to failures. So please use proper tools. Don't adopt any shortcuts to removal of the fasteners. And here, if you see, the most of the bogie components are critical items. So avoid reusing the hardware. Any screws, if needed, they have to be scrupulously, they have to be thoroughly checked before reusing. And my request to the railway workshops is to keep few spares of complete hardware set, so that if any missing in the service happens, it can be replaced. Then there are areas where thread locking adhesives is used for the tapped holes. So thread locking adhesive will be effective only when both the fastener as well as the tapped hole is free of any dirt, oil, grease, rust, etc. So use some cleaning solutions. So while assembling, we are taking care, but while in the railway workshops as well as in the maintenance sheds, you have to be careful while reusing the while providing the screws using the thread locking adhesives. And here in some areas we have used interlock washers. So I'll in interlock washers, actually they are two pairs of one pair of washer glued together. They are supplied as such. While using them, they while if you dismantle the washers, then please don't reuse them. Even though it can be reused, if you reassemble in a wrong direction, then the total purpose will be defeated. So do not use the disc lock washer. My recommendation is do not reuse the disc lock washer. If you are forced to reuse, then pay special attention for the proper engagement. If the cam surfaces like this, the serrated cam surfaces has to be mated against each other. Hello, anything? Somewhere somebody is asking some question. Okay.
There are some more issues. Hello.
Hello. Yes.
Hello. So there are some more issues reported by some railways, that a failure of spigot of air spring, and failure of safety ropes, and failure of dampers also.
Yes.
In 10 set bogies.
Okay. Actually the failure of air spring spike guards, it is due to the wrong assembly, or we can say the air spring spike guard is made up of actually in our regular 180 kN air spring, the air spring spike guard as well as the top plate, they are made from steel and they are welded together. In this, it is one of the, I think the top plate is aluminum, and they are screwing it to that with the steel spike guard. So there is some issues in that. So this time RDSO has highlighted this issue to the designer of this air spring suppliers, and they have promised to rectify this time. This time that type of failures will not happen. The sharing of spike guard will not happen. And dampers also, we have recommended that the issued the replacement of dampers should be between 2 POH, that is 6 years, that we have recommended. So we will check how the design change is going to help us. And then one more failure you were talking about. Hello.
Safety rope.
Spike guard.
Safety rope.
Are you talking about the wire rope?
Yeah. Safety rope, yeah.
Yes, this time the wire rope length has been slightly increased to take care of the failures. So actually, what we found is the bogie, without dismantling the bottom connections of wire rope, the car body was lifted, and that resulted in sharing of the wire rope belt. We had that. So we we have to educate our staff to these issues. They are not aware of the minute things. So we will try to conduct more classes so that this dismantling procedure can be explained to them.
Yeah.
Then
I agree with the modifications, but I think for dampers it will be problematic to change the dampers between two schedules, because as per board policy, almost bogie items should be guaranteed or warranted for up to 60 months or 72 months. So changing up these dampers in between, I think it will be problematic for us. And it is failing frequently. I think some dampers have also failed before the SS1 or some major schedule, prior to the major schedule.
Okay, sir. We will try to find a solution along with the supplier and with the RDSO, sir.
Yeah. Okay.
Next is this all the nuts provided in this bogie. They are all steel lock nut. That is the prevailing lock nut with the metallic inset. So here the locking element is metallic. It's metal. That is steel inset. So this is a costly nut imported from Plug and Pommel. So there may be problems in the procurement. So for the spares requirement, you can use nylock nuts in that area. If any nut is missing, and if you are unable to find a suitable FS also lock nut, you can use nylock nut, but don't use any plain nut. It will definitely lose in service. So use a prevailing torque type nut only. So the nylock nuts, the problem with the nylock nuts is it can be used only once. After that, the nylon it will lose its self-locking property. It has to be thrown away only. Whereas in the FS RC lock nuts, it can be used a few times. It can be reused. Though we have to replace, it has to be replaced in the during POH. By checking the nut, it can be reused few times. And being a precise bogie, we have recommended a lot of tightening torque. So if you see, you can see the tightening torque for the different fasteners: air spring, vertical damper, stabilizer link, and car body side of air spring. For the air damper, CP pin bottom side, it is 248 Newton meter. And the tightening sequence is in three steps. First step is 124 Newton meter. Second step is 168 Newton meter. And third step is for the complete tightening torque, 248 Newton meter. And then after tightening torque application, we are marking with the bolt head and the nut side also with the permanent marker or with some paint strip. So this will help you in during inspection of the rolling in examination or during the close examination of the bogie. So when you are replacing any component or any part, you have to ensure the tightening torque is provided and this marking is done. So you have to railway workshops and maintenance sheds. They have to equip yourselves with the suitable torque range for the entire bogie. This is very much essential. Please ensure this. And the CP pin bottom plate. We had some bitter experience in the Calcutta Metro because of the improper providing. So we have developed a procedure for this. So this is step-by-step procedure. If you see the bogie is without, it is without the car body now, it is free. So this traction center will come down due to the self weight. Now, before lowering the car body, this CP pin area has to be cleaned and applied with a thin layer of grease, and ensure the tapped holes in the CP pin are free from any dirt, moisture, grease, etc. So that the use of thread locking adhesive will be effective. If necessary, it has to be re-tapped. If you are using the new CP pin, you have to ensure that it is 45 mm depth, tapped holes are 45 mm depth. And now after lowering over the bogies, the CP pin will not straight away, it will not engage with the bush. There will be some gap in between the bush and the CP pin area. So from the underneath the traction center, it has to be pushed upwards using some bottle jacks, and this dimension has to be ensured. Actually now here in the CP pin, the tapered portion of CP pin and the bush, they are engaged now properly. This can be ensured by checking with this dimension. The gap should be 15 mm. And we have to use the thread locking adhesive. It is either Loctite 243 or Ranabond 122R. And the screws are also provided with disc lock or nod lock washers, that is interlock washers. Now it is engaged properly and the tightening is done. And then after tightening application, mark over the screw head. So this marking is essential for subsequent checking in service. You need not, every time you need not check with the spanner. Simply by seeing the marking alignment, you can ensure they are not loosened. That's all, sir. That's all, sir. That is all. This finishes my presentation on this bogie. Any questions?
Hello, good morning, sir. This is Tulsi Raman. Hello.
Yes, tell me, sir.
Hello, this is sir. In stabilizer, you have maintained two different shaft diameters, sir. Like in Fiat bogie, sir.
Two different shaft diameters. I didn't understand, sir.
Sir. Sorry, in anti-roll bar.
It is only one. There is
Hello?
no two. There is
One
no
unit.
two different. Only one diameter. Same diameter. It is reversible.
Okay, sir. Okay, sir. Okay, sir. That's only.
Bogie also we have corrected already.
Okay, sir. Okay, sir.
Bogie, yes, ICF has correct. ICF has made it as a uniform reversible. Okay.
Okay, sir. Okay, sir. Okay, sir. Okay, thank you, sir.
Very good. முடிஞ்சதுல
Sir, excuse me, sir. Please provide presentation.